Hello everyone, how you guys doing? My name is Angelo Juris. Welcome to today's live stream. What we're going to be doing today is going over some basic CAM toolpaths, creating a simple rectangular part and assigning some toolpaths, some contour, pocketing, a drilled hole. And then what I'm also going to do is show if you change the design or the model that you'll be able to quickly update your toolpath because it's all parametric. So again, my name is Angelo Juris. I'm with the Fusion Customer Success team here at Autodesk, and I focus on CAM and machining. Let me show you the part we're going to be programming. Here it is, basic rectangular part with the pocket and a few holes. Okay, so what we're going to do first, we're just going to run through this nice and easy. We're going to start with a brand new design. Very first thing we need to do is create a sketch. And we're going to create a sketch on a plane. And if you've been using Fusion, you already know that you need to start here. And me as a machinist, I always like to draw on the X and Y plane, but it doesn't really matter because when you create your WCS, you define your orientation. Some people like to draw that it matches the view cube here. Doesn't matter, but for today's demo, I will do that. So I'm going to select this X and Y plane. Very first thing I'm going to do is create a rectangle. So come here, create a center rectangle. Click there in the center, and I'm going to drag out. And the dimension here in Y will be 3 inches. We're using inch units here today. So I'll have that dimension 3 inches. And I'll use tab. And now I'll call this 5 inches over here. I'll now hit enter. And we've got our rectangle. I will finish that sketch. Next thing what I'm going to do is create an extrude. We're going to create on this face. We're going to extrude that up, and the thickness is going to be 3/4 of an inch. So now we've got our solid here. You can go about this a few different ways. You can add the holes. You could create the pocket. So what I'm going to do, I'm going to create the pocket next. And there's many ways to go about doing this. So what I'm going to do, I'm going to create another sketch on this face. Unzoom here a little bit. And one thing that I like to do is use, so for an example like this, I'm just going to use the offset. And I'm going to click on this edge. I'm going to drag this in. So it's really nice. It gives you a preview and then an approximate dimension that you're at. And the value I want is 1/2 inch. So I'm going to type in -0.5 and hit enter. So now we've got the geometry created for our pocket. I'm going to finish that sketch, and now what I need to do is cut or extrude that pocket down into the part. And you can see here, the cool thing about Fusion is over on the right hand side, as I'm moving my arrow, you can see it's creating a join or cut or new body. So I'm going to cut down into the part, and my value is going to be -0.5, 1/2 inch. So now we've got our pocket, pretty straightforward, and I need to add some fillets in the corners. So what I'm going to do over here in the modify up here, click fillet. And the cool thing about Fusion is you can select through geometry. So I'm hovering my mouse over, and you can see that it's just picking the edge. So I'm going to click these inner 4 corners. And I'm going to drag that in. And the cool thing, again, about Fusion is it gives you a preview. So when you're designing things, it gives you a preview so you can get an idea of what it looks like. And this value I want 3/8 of an inch. Okay, coming along nicely. So we've got a rectangle with the pocket and some fillets in the corner. Next thing we want to do is create those through holes, and I'm going to create another sketch on this face. And again, for this example, I'm just going to use the offset command. I'm going to click on that outer edge and I'm going to drag it in. Now you can see the preview is this red or orange. To me it looks red. It gives you a preview of where that line is. One thing I want to make sure that I do here is make sure that that's construction geometry. Now you can see it's a dashed line. Here it's solid line. Dashed line. So what that is, if you can imagine, if you're drawing a mechanical drawing with a pencil and you got the heavy dark lines defining the part, and if you have, say, a circle and you're defining the phantom line in the center. So if you got your mechanical drawing and you've got the heavy lines for your drawing defining the part, and then if you have like the center lines, you can create it like a nice light faint line. So that's what this is here. Okay, so one thing I want to do here, so I want to make this value minus 0.25 so that that line is created right in the center of that top ledge of the part. I'm going to finish the sketch now. Now I'm going to add some holes. So I've got up here in the create, I'm going to create a hole. Up here on placement, I'm going to click multi, and then I'm just going to select the 4 corners. Few things here to note. You can give a distance. So distance would be how deep is the hole. You can also go to, so if I wanted to click to, and I can rotate the part here, and I can say to the back of the part there. But in this case, I'm going to make it a blind hole. I'm going to create the dimension of 0.5. And a couple of things here on the hole type. You can create a simple hole, a counterbore hole, or a countersink hole. I call it countersunk hole. And then the depth we've got defined is 1/2 inch. The countersink, I'm going to call it, because the hole is going to be 1/4 inch, and I want a nice 30 thousandths or 15 thousandths per side chamfer. So I'm going to call the diameter here on the top 280. The spot drill that I'm going to use is 90 degrees. So I want that chamfer to be 90. And then the drill tip is going to be 118, and then the diameter of the hole is 1/4 inch. I'll hit OK. And there we go. So now we've got a part, rectangular part with the pocket and a couple of through holes. Nothing too complicated here, but what we're going to do now is go to the workspace of the manufacturing here. So this used to be called CAM, Computer Aided Manufacturing, and some people were freaking out or thinking, oh, why'd you change it to manufacture? Well, if you think about it, CAM is Computer Aided Manufacturing. So that is why we renamed it manufacturing. All right, so the very first thing here in the manufacture tab, you can see our tools here at the top changed. We want to create a setup. And in the setup is where we define the workpiece and the orientation and those types of things. So I'm going to click a setup. When you look here on the right hand side, we've got our dialog box. In the setup we have a few options. Operation type we're going to do today is milling, and we've got a few other things we'll go over in some future live streams. We've got turning, mill turn, we've got cutting, which is laser, water jet, plasma, those types of things. And so what we're going to focus on today is milling. And what we need to do is define our WCS, or work coordinate system. So one thing I like to do as a machinist, I like to be in control of what I'm doing here. So I personally prefer Z-axis and then the X-axis. So once I click that, you can see here Z-axis is highlighted blue. So what Fusion is looking for is some information. So I can click a face. So see, when I hover my mouse, it's now changing to a lighter color. And then after I do that, you can see it recognizes that face that I selected. Then it automatically jumps over to X. Now it's looking for an X. I really don't have to do this because I drew it in the right orientation, but what I'm doing is just showing you the workflow. So now we've got a face defining X, we've got a face defining Z. A couple things here, you can click this to change the orientation of the Z. You can change the orientation of X. A few other tips here, if you come over, you can click on the arrowhead and it'll flip it into the other direction, which is quite cool. And then coming down here to origin, this is when you're setting up your CNC machine and your G54, for example, your work offset. That's what this is right here, so your origin. And right now, by default, it came up to stock box point. And you can do things like model box point. And what that does, what Fusion does, it creates a point at the endpoints and midpoints of all the geometry. So you can see I can set it there. I don't know why I would do that, but it's there for many reasons. Here, I can click that corner. I can do bottom left corner. I can do bottom center. Things of that nature. So what I'm going to do here for today's demo, just keep it simple. We're going to do stock box point, and I'm going to pick this top left corner. Another thing we need to make sure of, so Fusion automatically recognized the body, and now you can see it's highlighted in blue. But anytime you're having any issues in Fusion, this is one of the first places I look. So if you have an assembly, make sure you have the right parts selected. And we'll be covering more of that in some future live streams. On the next tab here is stock. So this is where we're defining the size of our stock. So you can see the part, we've already designed the part, and Fusion is automatically recognizing that and creating, in this case, a boundary around that by default relative size box. So we've got some options here, relative size box. So if you hover your mouse, the cool thing about Fusion is it shows you a tooltip and it gives you some input. So if we keep it here to the relative size box, and on the sides we want to add, let's say 100 thousandths, and on the top if we wanted to leave 20 thousandths, and on the bottom, and as I'm entering information here, you can see the stock will update. So if I put a 1/4 inch there, you can see if I orient here, watch this. So now if I change this to 0.5, now it's thicker. So I'll be holding this part in a vise, and I'll be holding on the bottom part of the material there. So I'll be holding in this area. So for today's example, let's give it 0.230, just so that I have a realistic size stock. This Y, so I can give it a little more. I can give it here something like this. I can go 125. So now you can see here on the dimensions, it's giving you the size stock that you'll need. So if you go out to your shop and you cut some stock, the X dimension will be 5 1/4, the Y will be 3 1/4, and the height in Z will be 1 inch. So as you're updating this, and in future live streams, we're going to cover more of this in more depth. But this is just an intro to CAM, keeping it simple and straightforward. And I'm going to leave it like this with these settings. Next tab here, post-process. This is where you define your program number. Let's call that 1. And here on program comment, we'll call it live stream. Over here under machine WCS, so earlier you heard me talk about your machine work coordinate system, or G54 is the default. Over here in Fusion, if you have a value of 0, that represents G54. If you have a 1, that also represents G54. If you wanted to do G55, you can put a number 2 here. And if you want to use G56, you would put a 3 here, and so on. For this demo, we'll just leave it at 1. 0 would give us the same result. I'm going to hit OK. So now we've got our setup, we've got our part defined, we've got our WCS defined here, and we've got our stock. So what we need to do now is create some toolpath. So we were in this area here of the Fusion. Now next to it we've got the 2D toolpaths. And if you click on that down arrow, we've got some options here: 2D adaptive clearing, 2D pocket, face, 2D contour, and so on. We'll be covering all of these over time in these live streams. What I'm going to do here today, just going to use a face, very straightforward. And then this dialog box appears here on the right hand side. The very first thing in Fusion what we need to do is select a tool. So once I click that, it's going to come up with this area, and I was just using it earlier before this live stream, and you can see I was using the filter here. I'm going to clear that filter. We've got these sample libraries. So you got all of these come with Fusion. You check them, you uncheck them. So the document is basically what you're working on or what tabs are open. That's what you have here in the documents. Cloud, I'll go over that more in detail in another live stream. We've got all these samples, and for today's demo I'm gonna want to isolate it to that one and the tutorial inch. So going back to what we were doing here, we were facing. We selected face. Excuse me. And I want to select my facing tool. And now that I have this highlighted here in the libraries, the very first tool here is a 2-inch face mill, and that's actually the one that I want. So I'm going to click that. It gives you a preview of the tool, some information here. I'm going to hit OK. Shows a preview of the tool nicely. And I'm just going to hit OK and see what Fusion gives me. The defaults are very robust and solid, and many times in Fusion you just need to select what you want to do, like pocket or contour or drill, and select your tool. And in the facing, it's very simple. You just select your tool. Fusion automatically recognizes the top of the stock and the top of the part and gives you a toolpath. So if I view it from the front view, you can see we get a nice entry here and machine the top of the face. So there's our toolpath for facing. The next thing I want to do now is rough. So I can go about this a few ways. I can contour the outside. I can do a pocket. I can do a 2D pocket. I can do adaptive clearing, and that's what I'm going to do here. I like adaptive clearing. It's model aware. It looks at the model and it looks at the stock, and it creates a toolpath based on those settings. And again, like I said earlier, we're going to be covering all of that in these weekly live streams. So we've got our facing done. Next thing I'm going to do is use the adaptive clearing. And when I select adaptive clearing, first thing it needs to know is what tool am I using. So I'll go to my tool here. I'm going to scroll down here to the inch, and I can do a few things. I can search through it here. One thing I really like about Fusion is you can select, or filter I should say, by type of a tool. So I'm going to click type. I'm going to go to flat and hit OK. And now all the tools that are in this library that are flat end mills will show here. And the one that I want is the 1/2-inch flat end mill. Gives me a preview here. I'll hit OK. All these feeds and speeds are over here. I'm not going to get into details today about speeds and feeds, but you would update those here. We've got geometry, we've got heights, we have passes, and we have linking. The cool thing about Fusion is all of these tabs, they're all the same. So when you go from toolpath to toolpath, or just selecting things is very simple. So it's very consistent throughout the product. What I want to focus on here is the heights. And by default, it's right now selected to model bottom. So if I go to the front here, you can see this dark blue line here. So the tool will go to the bottom there. But what I want to do is go beyond that a little bit. I'll say 30,000. So you can see as I change that blue line the highlight preview there, it updated. So if I do, for example, minus 0.1, you can see that big gap. I'll just do, in this case, minus 30 thousandths. I'm going to hit OK and see what we get. So we've got a nice toolpath here. Fusion created a pocket and machined around the outside. A couple things of note. If we edit this on the Passes tab, here's a few things to pay attention to. Optimal load. So optimal load, that's basically the step over. And I've got this expression here. So if I go into here and if I right click and I go to edit expression, I have a formula here saying whatever the tool diameter times 0.2, that's 20% of the tool diameter. So the cool thing about that is anytime in Fusion, if you say, so for example, in this part we're doing a 1/2 inch tool. If I want to change it to a 3/4 tool or a 1/4 inch tool, Fusion will automatically update the step over according to the tool diameter. So I come back over here. By default, when you use adaptive clearing, stock to leave is on, and it's leaving 20 thousandths radially and 20 thousandths axially. So that's the Z direction, and that's in the X and Y, the radius of the tool. A couple other things to look at here under linking. Again, like I said earlier, we'll get more in depth later on in more live streams. But a couple of things I like to do: maximum stay down distance. So if I hover over that, you can see that it gives you a preview of what it looks like. So if you don't want the tool lifting and retracting, I like to sometimes give it a dimension of basically what the part is. Non-engagement feed, so that is when it's moving, when it's not in the cut. How fast is it moving? Ramp type, you've got a few different ramp types. You can pre-drill, plunge, helix. In this case, I'm using helix. One thing I really like about Fusion is, again, like I said earlier, if you hover your mouse over, it gives you a preview of what this feature does. So on this case here, the helix, you've got the ramp taper angle. So what that does is, as the tool is ramping down, it's not going straight down vertically and recutting chips. It actually tapers down so it doesn't recut your chips. And sometimes if you're in front of the machine and you're doing some cut like this, you can hear the gargling as it's cutting chips. So this is a nice feature that adaptive roughing does. Ramp clearance height, that's another thing to be aware of. That is, before it enters the cut, it rapids down, it engages and starts cutting here. I'm not going to worry about these, but if you have a pre-drill, if you drill a hole prior, you can enter that information there. So we'll hit OK. Got a nice toolpath here. Next thing, we're going to contour around the outside of the part, and then we're going to finish that pocket. And if you remember in adaptive, we did a stock to leave. We left 20 thousandths on the walls and on the floor. And if you also think back to when I'll just go back to it here. On the passes, I said here, leave 20 thousandths on the X and Y, leave 20 thousandths on the floor. So if here under the height, where it's actually going down to is minus 10 thousandths. So next thing we're going to do here, we're going to create a 2D contour. It remembers the last tool that we've used, and I'm going to just click this outer edge here. A couple things to look at here. So we've got this red arrow, and if I go to the top view here, so what the red arrow does when I click on that geometry, it tells Fusion the side of the part it's going to be cutting on, the direction it's going to be cutting, and actually the distance from the arrow to the edge of the part is the radius of your tool. So some CAM software, it'll show like a preview, like a diameter of the tool. So this is basically where the center of the tool would be. And obviously, so this tool is 1/2 inch. So the distance from here to here is 1/4 inch. And if my tool was bigger, obviously the arrow would be a little bit lower. So this red arrow serves three purposes. Again, it shows you the direction it's cutting, the side of the part, and then the radius of the tool. I'm going to go to the next tab here under heights. And over here, the bottom height, I told it's by default on selected contour, and I wanted to go past that by 20 thousandths. So I hit OK there. And if we view it from the front now, we can see we've got a nice toolpath. It's going below the part by 20 thousandths. And one thing I need to go back to verify, let's double check here under the passes tab. One thing to verify is your stock to leave. Make sure if this is a finish cut that you have that turned off. So there we have it. We've got a nice contour on the outside. Next thing we're going to do, we need to machine this inner pocket. It's already been roughed out by Fusion, and there's 20 thousandths of stock here on the floor and 20 thousandths of stock on the walls. I'm going to come into here and do 2D pocket. Again, Fusion remembers the last tool you used, and sometimes you want to use a different tool for roughing and a different tool for finishing. For today's demo, we're just using the same tool. We've got our tool selected here. Again, you can change speeds and feeds. All of that information is right here, easy to access. And I'm going to click on this edge. Again, you can see our arrow. It's showing the direction and the side. And I'm just going to verify that on the passes tab that stock to leave is turned off. I'm going to hit OK. And we've got a nice finishing toolpath. It's machining the floor and the walls. But there's a few things that I'm going to change here. As a machinist, I don't like to waste time cutting air. So you can see what it's doing. It's starting here, rapiding down, feeding down in Z, and then spiraling in from the top. One trick that I like to use, and actually CJ Abraham, my colleague, uses this, and that's where I picked it up from. I'm going to edit this operation, and on the heights tab, on the top height, so it's going to the selected contour. Remember, I selected this edge to the bottom, and it's going to start machining from the top height. So one thing that I'm going to do is selection, and I'm going to click this face. Now that that face is selected, I'm going to say offset 0.1. So begin machining 100 thousandths above that. So I have a positive value here. And now if I hit OK, you can see the toolpath change. So now it rapids down into the part and then starts feeding closer. So it's less air cutting. Another thing I like to do on a pocket like this, if I right click and edit, and I go over to the passes tab, I'm going to give it a finishing pass, and I'm going to tell it give a finishing pass of 5 thousandths on the wall. Stock to leave, I'm verified that that's off. I'm going to hit OK. Now you can see what it did. It added a 5 thousandths finish pass on the wall. So let me go back and remove that so you can see the difference. I'll uncheck that. And now you can see that 5 thousandths finishing pass is gone. I'm going to return with a right click, edit that, turn that back on. And one thing I forgot to check is verify the step over is 5 thousandths. All right, so there's our toolpath. So we've faced the part, we've roughed the part, we contour finished around the outside, We did a pocket with the 5/1000 finish pass on the inside. Next thing we're going to do is we need to drill these holes. We need to spot drill it, drill the hole. We need to chamfer around the outside and deburr the part. So you can do it in any order you please. I usually save all the deburring for last. And then, so in this case, I'm going to go to drilling. Again, first thing I need to do, select my tool. I'm going to go to inch here. A few things, like I said earlier, I can filter by tools. You can see here hole making, so I'll hit OK. The hole is a 1/4 inch diameter, so I'm going to select a 3/8 90-degree spot drill. I'll hit OK. And Fusion now needs to know what it's drilling or what it's doing. A few ways to go about it. When I'm doing a spot drill, and if I have a chamfer already modeled, Fusion is asking for the hole face. So I'm going to click that hole face, and it already gives me a preview. It's quite cool. So if I look at it from the side, it's giving me a preview of what it's doing. I can go through and select all these faces. One awesome thing that we can do here, select same diameter. So Fusion will now detect all the like sizes. If it's the same, it will find it. So if you have 4 holes in this case, or if you have 50 holes, it'll find them. So you don't have to go waste time and click each face individually. Heights tab, that's all by default. I'm going to leave that here. And when I click the face, it automatically detected that face. And I'll get more into detail on these, like if you change your model, how all that works, or if you change the if you select the inner face and then the bottom and all of that, how that all works. I'll be covering all of this in detail in future live streams. Next thing we need to do here is verify the type of cycle we're drilling. So on your machine, you've got spot drilling. You can counterbore. You can do a G81, for example, just a regular drill. You can do a G83 peck drilling. You can do a G73 chip breaking cycle. So this is where you control it here. So drilling would be your G81, counterboring, chip breaking. Remember how I just described all that? So I'm going to do a dwell and wrap it out. In my dwell, I'm going to select 0.3 and hit OK. So now we've got our spot drill with the dwell, and the reason why I do the spot drill with the dwell is if you can imagine a drill press or a milling machine, a Bridgeport, and if you're countersinking a hole, and when you put your countersink in and you pull that handle down, and then the drill or countersink comes down, you want it to sit there for a moment and get that face that you're cutting. You want that nice and smooth and clean. And the way CNC machines work is they're always looking ahead. It's always reading the code ahead. So one thing I've noticed on machines, if you don't tell it to dwell in a countersink or a counterbore, what will happen, because I said it's always thinking ahead, it'll come down and already be thinking, so I'm feeding down and now I need to wrap it out. So it never really hits that bottom, the bottom in Z to make a nice few revolutions there and then come out. So you don't get a nice, consistent, beautiful finish. So that's why I use the G82 with the dwell, so that it comes down, does a few revolutions, and then creates a nice finish and then rapids out. Okay, so now we've got our spot drill. Next thing we need to do is drill that through hole. Again, I'm going to come here to drill. We need to select the tool, so that's a 1/4 inch through hole. I have some options here. I can create a new tool, or I can come in here to my library. I can here in the search type in 1/4 to filter out by all the 1/4 inch tools that are in this library. And this is a tool I want. 1/4 inch drill. Hit OK. Again, like we did in the previous operation, Fusion needs to know what it's drilling and the whole face it needs. So now there's nothing selected. I'm going to select this face and it gives a preview. And like I said earlier, select same diameter. Awesome feature here. Fusion's going to find it. Next tab over here is the heights. By default, it automatically will select the whole bottom. So let me go to the front view here so you can see what's happening. So it's giving a preview of what's happening here with the tool. Let me go back one tab here. Auto merge whole segments. We'll be covering more of that in future live streams. So if you have a counterboard hole or a pipe or tube or something like that, it will detect all of that for you. I'm gonna not worry about that in this live stream. On the heights, so here's a few things that we need to pay attention to. The drill tip through bottom. So if you hover over with your mouse, it'll give you a preview. So by default, like I said, it'll go to the whole bottom. So the tip of the drill will go to the bottom of the hole. But if you want the shoulder or the diameter of the drill to go to the bottom, you would need to select this. And then if you want to go additional distance, you can give it a value here. So you can see now I typed in 1/2 inch and you can see it went beyond the bottom by 1/2 inch. You can do 100 thousandths. Oops, I have too many decimal points there. Things like that. So I'm just gonna go to the bottom of the hole that I defined. I'm gonna leave that 0. And then the cycle, we need to give it, we're gonna do deep hole drilling with the full retract. Pecking depth. So this is if you're doing a G83. And the Q value is the pecking amount. This right now is 0.0625. Few things you can do is if you right click, the cool thing about Fusion, excuse me, you can right click and create an expression or a formula. So right now it's set to whatever the tool diameter is, 25% of that. Some people like to do 0.5, some people like to do 1, some people like to do 3 times. Whatever your preference is, obviously different materials, different tools need different parameters. So let's keep it at 0.5 for now. I'll hit OK. So now, my tool is 1/4 inch diameter, and the pecking depth is half of that, which is 1/8. If I wanted to retain it to always be what I have there, 0.5 or 50% of the diameter, I would right click and say make default. So now moving forward, anytime I was drilling a hole with the deep drilling cycle, it would be half the diameter. So if it's a 1/2 inch tool, it would be 1/4 inch. Very easy. I'm not going to worry about a dwell in this case and hit OK. So now we've got our drilled hole. We've got right before we did a spot drill and it already chamfered the top of the hole. We've got the drill and our part's almost done. We just now need to deburr around the top edges. 2D chamfer. First thing we need to do, select our tool. I'm going to see what I have in this library. And I can remove that and go to type and chamfer. Let's see what I have in this library. So I've got these tools here I could use. I could also come down here. We've got tutorial inch. I'm going to use this tool here. The filter's on for chamfer mills. And I'm going to use this tool here. We're going to tell it what we're going to deburr or chamfer. I need to give it some geometry. So right now nothing is selected. I'll click on this edge, click on this edge. Heights, I'm not going to worry about any settings there. By default it's going off the selected contour. And passes. This is where I want to give some attention and information on chamfer width. So like I said earlier, the cool thing about Fusion, when you hover your mouse, you get a tooltip. So this is basically what size chamfer are you cutting on the part. I'm going to give it a 20 thousandths chamfer. Chamfer tip offset, if I hover over that, that is how deep past the edge is the tool going. And this comes into play if you have different geometry pockets with steps where you want to make sure the tip of the tool doesn't hit the bottom of the pocket or floor of the part. We've got this pocket here is 1/2 inch deep, so we're not concerned about that. There are some things you can do to drive the shank or the shaft of the tool away from the wall of the part. That we'll cover in some more live streams where there's more detailed of a part, but that's what you enter here. I'll just do let's do 50 thousandths, and I have too many decimal points. If I have something wrong, Fusion will highlight it in red to tell you something's not quite right there. I'll do 50 thousandths there, and this here chamfer clearance. Again, if you have a part like in that tooltip there, you see a part with a step and you want to deburr it. It's a clearance for collision avoidance, is how far the shank of the tool will stay away from hitting that vertical wall. And we don't have to worry about that in this part here. We've got a nice toolpath here, deburring at 20 thousandths all the way around. So that basically covers the whole part. So we faced the part, we roughed the part. Let me do it this way. So we faced the part, we roughed the part, we contoured around the outside, we did a pocket to finish the inside, we did a drill to spot drill it and chamfer, and then we drilled the through hole. Actually, not a through hole, it's a blind hole, but I'm going to show you some cool things about Fusion. And then we deburr the top edge. So that's pretty much it on this, what we're going to do here. And then the other thing I wanted to point out, let's say you design this part and you're machining it and you realize, oh no, I made a mistake. I need to add some holes. Let's say we've got 4 holes now. If we wanted to make 8 holes, so we had a hole here, and if we had a hole here, let's go back into our design. And now what we can do in here, we go to, in the bottom we have this timeline, and what we want to do is go into the sketch, and we'll right click, we'll edit that sketch, and what I want to do is add a couple of points. So I'm going to add a point here, and as you can see, as I hover my mouse, it's snapping there on the line, and as I get to the center, it's giving that triangle symbol. That's the midpoint of this vertical line. That's the end point of the line. So I'll put a point there. I'll come to the midpoint here. We'll put a point here. We'll put a point there, and then we'll put another one. Verify we have that triangle. So now we got 4 points that we've added. I'm going to finish my sketch, and then we're going to now go in the timeline here where we added the hole. We're going to right click that, edit the feature, and you can see here in sketch points, we've already selected the endpoints of those lines where the corners were here. And now I'm just going to click on this here, this one here, that right there, and there. I'm going to hit OK. So now we've got 8 holes in our design. And now when I go to manufacture, I have all this red here. So this red says, hey, Fusion detects that something's changed in the model and the toolpath needs to be regenerated. If I right click, I'll hit generate. Now all of the red the red went away, and this is what I want to show you. Look at that. Fusion automatically picked up those holes because I told it select same diameter. So if I added 4 holes, it picked it up. If I added 50 holes, it would automatically pick those up. That's one thing. One of the cool things I like about parametric, how Fusion is parametric, it's all tied together. So other CAM software is if you have you import a solid model and then you assign a toolpath, it's not tied to the original model that the engineer sent to you. So that's one of the things that I really enjoy about Fusion, is if you just change your design, the toolpath automatically updates. Another cool thing I like to show is what if now, so this part, if you remember, we designed it, it was 3 inches by 5 inches. You can go back into the design and change it. What if we now go back here in the first sketch we created, we right click, edit, and now let me make this viewable here, and if this value here is now 4 inches and this value here is 4 inches, I'll double click that, and now it's a square. I'll hit finish sketch. Now we've got a square with 8 holes. I come over here to manufacture, and again Fusion detected that something happened. I can right click, generate. It's recalculating, and all of our toolpaths automatically update. That is just awesome. That's a cool feature of Fusion. So I can right click here, I can simulate now. Let me back up here. So if I right click and I simulate, if I go to this operation here at the very beginning, I hit play, I could turn on my stock and just simulate the part being machined. So you get a nice preview. You can speed it up here. You can slow it down. You can even go in reverse if you go beyond the center line. Now it's going in reverse. But anyway, let's go back here. You can also show transparent. So your stock is transparent. You have some options here. As that's cutting, I'll show this all. It'll show everything. I personally like tail. So it's basically a tail of the toolpath following. So now we've got our part machine. You can see a nice visual representation of that. And the part is done. And what I'll do on the next live stream is I'll show how you could machine the other side. Oh yeah. One other thing that we need to do, we need to get code to the machine. Because if you can't get code to your CNC machine, you can't cut it. So over here under Actions Post Process, you've got a few options here. You've got generic post, personal post, my cloud post. I'll go more into detail of this in another live stream. By default, right? So what I have now selected is generic HAWS. And again, if you remember in our setup, we told it the program number is 1 and the comment was live stream. I'm just going to hit OK. Now it's asking where are you going to save your code. I'll hit save. I'm going to replace one that I've already created, and there's our code. So you can see there's our code. We got our comment, and there's our tools. And now what you would do, you would save this code to a USB stick or something like that, or through the network, connect to your machine, and then run your part. So that's basically what we need to make this part. So I'm not going to go into any more details here. I just want to start with a basic understanding of how Fusion works and how we create a toolpath, how we design a part, how we make some changes, how we assign some toolpath to it. Will be my colleague and I, Brad Tallis. He's doing the live streams and showing how to design a part. I'll be showing how to machine the part. So one thing we've talked about that we will be covering is one day he'll design a part, and another live stream I'll machine the part. So look for those coming up. If you have any questions or comments, put that in the comments. If you have any ideas or suggestions or questions, feel free to let us know. And I hope you all have a great day and hope this was valuable to you guys. See you next time. Cheers.